In the current unit of work on statistics, we've looked at a couple of key concepts, the first being looking at measures of central tendency, and we should be quite familiar with that. At the moment, we would know those measures as being the mean, we'd look at the median, and we look at the mode. And they're the three common measurements of how data can be represented using a measure of that centralness if given a group of a group or a sample of data. The second thing that we've looked at is what we call the measures of spread, and we've got a number of those examples. We've looked at things like range. We've looked at interquartile range, commonly known as IQR sometimes when we see it written down, and we've looked at graphical ways of measures of spread. So we've looked at box and whisker plots, commonly known sometimes as box plots, and we've also used stem and leaf plots as well. Also known as stem plots. So we've used graphical methods to have a look at the spread of data. They also look at measure, the centralness of the data. But in particular, stem and leaf plots. Box and whisker plots show up. The median and the interquartile range, or the Q1 and Q3. But they're quite good for looking at spread in the way that they're represented. Today's lesson, we're going to have a look at one more measure of spread, and we're going to have a look at what we call the standard deviation. And the standard deviation is a really good one for looking at spread. It actually tells us a little bit more about the specific spread of the data in the sample. And you may have heard this mentioned before. You might have heard what we call the bell curve. And essentially the bell curve describes a distribution of data where around the mean, so which is obviously our measure of central tendency, around the mean, data tends to be clumped or focused around that mean point. So you would find that the belly of the data in a particular sample set would be very close to the mean, and then you have the data at the top end and also the data at the bottom end. So you could probably relate this to potentially marks in a class, or and so let's have a talk about a maths class. We would talk about the mean being the measure here of that centralness. Most of the class would be gathered around that mean, and then you would have your really top achievers at the bottom, and I guess we need to talk about the strugglers. The high achievers here at the top, and potentially the strugglers at the bottom. So a curve or a distribution of data like this is quite often what we refer to as a normal distribution. And when we start talking about standard deviations, we talk about the percentage of the number of data points, or the percentage of data that lies away or within the mean. So, and we talk about three particular measurements. So if we were to talk here, we have one standard deviation from the mean, and that normally contains 34.1% of the sample. If you were to go this way and go -1 that way, you would also have 31.1% there. Right, if we were then to look at have a look at going 2 standard deviations away from the mean, and So we go -2 this way and 2 standard deviations that way. We end up having 13, and this is what and they're quite specific percentages, 13.6% that lie in here and lies in here. Right, of our data lies within that boundary between 1 and 2 standard deviations. So if you were to add this all up at the moment, you've got 68.2% at the top here, or within 1 standard deviation either side, and then we're obviously adding another 13.6 either side in this area here. So within 3 standard deviations of the mean, so -3 or 3 below and 3 above, 3 standard deviations, we have what we call 2.1% of the population above, and then obviously there's another 2.1% here as well. Now if you were to do a quick little add up of all of that there, if I was to do my numbers there, I'd have 68.2%, I'd have 13.6 times 2, which is going to give me 27.2%, and I'm going to have 4.2 there. You can see here that if we were to add that up there, we get 99.6% there. So it doesn't quite include the whole 100. There's a slight amount, or a slight percentage of data that lies above that 3 standard deviations, but 3 standard deviations above and below generally captures most of the population. Now when we're looking at standard deviation, you'll notice that it is written as that little squiggly symbol there. Our little squiggly character is referred to as sigma, and you will have heard that at some point before. We talked about sigma there not long ago. This is the lowercase representation of that. So standard deviation, the lowercase sigma there. So 1 standard deviation, 2 standard deviation, 3 standard deviation.